SpaceX's Starship test site Massey is rebuilding fast, and Starbase is about to start possibly its most important project this year. Starship Block 3 is progressing quicker than expected. The third interstellar object is visiting our solar system. What can we learn from it before it zips through? And we're talking about a galactic collision. The James Webb Space Telescope has some new insights. My name is Felix, welcome to What About It. Let's dive right in. Something strange is passing through our solar system right now, and this time astronomers are ready. On July 1st, a NASA-funded survey telescope in Chile picked up something unusual. A faint but fast-moving object arriving from the direction of the constellation Sagittarius. That object has now been confirmed as a comet, and more importantly, it's not from around here. It's like the universe tossed us a message in a bottle and we've got 6 months to read it before it floats off again. And only if we can find room in our budget to study it. The comet is officially named 3I Atlas. 3I because it's only the third interstellar object ever discovered. In other words, it came from outside our solar system, from where the aliens are. It's been traveling through interstellar space for who knows how long, billions of years likely. And by sheer cosmic luck, it just happened to cross paths with us. The discovery was made by the Asteroid Terrestrial Impact Last Alert System Telescope, or ATLAS, in Rio Hurtado, Chile, which is designed to scan the skies for fast-moving near-Earth objects. After the first sighting, astronomers went digging through archival data from other telescopes around the world and found earlier traces of the object dating back to mid-June. That extra data confirmed its trajectory and revealed what made this comet truly unique. It is moving on a hyperbolic orbit, meaning it's not gravitationally bound to the Sun. Everything else in the solar system is. Most comets loop around the solar system in long elliptical orbits, coming back again and again over centuries. But a hyperbolic orbit means this object is just passing through on a one-way trip. It came from interstellar space, and once it swings around the Sun this fall, it'll head back out, never to return. These kinds of objects are extraordinarily rare. Until 2017 we had never seen one before. That year, astronomers discovered Oumuamua, a strange oblong object that was already speeding away from the Sun by the time we noticed it. It had no visible tail, spun erratically, and sparked endless speculation. 2 years later came 2I Borisov, the first true interstellar comet ever observed in detail with a visible tail and gas emissions. And now, 6 years after Borisov, comes 3I Atlas, a third cosmic interloper and another piece of the puzzle. So why does this matter? Because interstellar objects carry material that formed around other stars. Interstellar literally means from between the stars. So it came from another star system. How insane is that? Long ago, in some distant planetary system, this comet was probably part of a primordial debris cloud, the same kind of stuff that once built planets and moons in our own solar system. But instead of settling into a stable orbit, something, maybe a giant planet or a gravitational tug from a sibling star, kicked it out. Ever since, it's been drifting through interstellar space, and now for a brief moment we have a chance to study it. That is incredibly valuable. These objects are natural probes from other solar systems, fragments of places we can't yet reach with our own spacecraft. Studying their composition, shape, and behavior gives us clues about how different or similar those other systems might be. They could contain unfamiliar ices, unusual dust grains, or even organic materials that never formed in our own corner of the galaxy. We don't know, and that is what makes it so interesting. Right now, 3I Atlas is about 420 million miles from Earth and closing in on the Sun. That's a total coincidence. It's expected to reach its closest point in late October, passing just inside the orbit of Mars. Astronomers around the world are using every telescope they can to collect data before it moves out of view. It should remain visible through September, but by October it'll get so close to the Sun's glare that it can't be observed anymore. One interesting aspect is that Atlas is an icy comet. Ice could mean organic compounds, and organic compounds measured from outside our solar system would give us more proof that life could exist outside of our solar system. While it's thrilling to catch one of these rare objects in real time, it also points to something bigger. The fact that we've now detected 3 of them, all since 2017, tells us that these visitors may not be as rare as we once thought. Our telescopes and survey systems are improving fast, and cutting-edge observatories like the Vera C. Rubin Observatory, which just went into operation, could uncover many more. We are on the edge of an entirely new era of discovery. For now though, all eyes are on 3i Atlas, a frozen traveler from another star system, briefly lighting up our sky as it continues its long journey through the galaxy. The average person is spending half their day online. The internet has become an integral part of our daily lives. But are you aware of digital threats waiting for you in the online world? What's more is that they are putting your children, parents, those you love in danger too. Surfshark is the sponsor of today's video, being the go-to VPN keeping you and your family's data secure. It creates a private network keeping out whoever doesn't belong there, just like virtually locking your door. With a built-in antivirus to protect you from dangers like data worms and Trojan horses, the Surfshark One cybersecurity package has got you covered. And it is easy, handling everything for you, including proxy emails, instant alerts, and a fresh start if your data was compromised. It protects you online, both in your own home or when you travel. And you can use it on as many devices as you like. A single license protects your family with ease. Create a new standard for your family's security. Go to surfshark.com/Felix or use code Felix at checkout to get 4 extra months of Surfshark VPN. The link is in the description and in the pinned comment. Surfshark, your data, your rules. NASA's newest space telescope, Spherex, has officially begun operations, and it's already sent back its first images. Now in low Earth orbit, the telescope is streaming weekly observations into a public archive just 60 days after capture. It's giving scientists and the public access to some of the most detailed all-sky infrared data ever collected. Yeah, you can look into it. Spherex maps the entire sky twice a year in 102 different infrared wavelengths. This is a huge leap from past missions like WISE, which observed just 4 wavelengths. This wide spectrum allows researchers to detect signatures of specific molecules like frozen water and organic compounds spread throughout the Milky Way. These are clues to where the ingredients for life tend to gather. Beyond our galaxy, Spherex is also tracking the faint glow of billions of galaxies to measure how the universe expanded after the Big Bang. Those patterns help refine models of dark energy and give scientists a better handle on the timeline of cosmic evolution. The real strength of Spherex is in how it links up with other observatories. It's basically the Google Earth of the entire universe, except with 102 filters and sadly no street view. Its broad survey can identify promising targets for JWST, support exoplanet data from TESS, and complement galaxy-scale studies from Euclid and the upcoming Roman Space Telescope. Gathering more data every week, Spherex is already becoming a vital tool across multiple fields of astronomy. By the end of its 2-year mission, the telescope will have produced 4 full sky maps, each one packed with new clues about the structure and chemistry of the universe. That's 4 complete maps of the entire sky in more detail than we've ever had before. Before we continue with Starship news, hit the subscribe button to stay informed. Like this video if it brought you value, and become a WISE supporter for extra content. Secure your access to a huge amount of extra content: picture galleries, satellite, helicopter and ground photos, and 3D animations. Chat with me and gain more insights on the topic you love. The entire team is waiting for you, you rock! SpaceX is building a major new piece of infrastructure at Starbase, and it's not a tank farm or another launch mount. It's an air separation unit, or ASU, a facility that will allow them to produce their own liquid oxygen on site. The new system is designed to extract nitrogen and oxygen directly from the atmosphere, cool them into cryogenic form, and store them in tanks for launches. That means SpaceX won't need to truck in liquid oxygen or rely on deliveries from outside suppliers. Instead, they'll generate it just a few hundred meters from the pad. This is part of a broader push to make Starbase more self-sufficient, especially as the launch cadence ramps up. The scale of Starship launches requires enormous volumes of liquid oxygen. Producing it locally gives SpaceX more control, more reliability, and fewer bottlenecks on Highway 4, the single access road to the site. And just how much easier will this make things for SpaceX? How many oxygen tanker trucks from outside Starbase are needed to fill a Starship? Let's put it into perspective. A Starship upper stage holds 1,500 tons of propellant. The booster stage holds another 3,400, and we're talking Block 2 here. Raptor operates with an oxygen to methane mixture ratio of about 3.6 to 1. That comes down to 3,834.8 tons of oxygen per full stack. A standard oxygen tanker truck holds approximately 24 tons of oxygen when it arrives at Starbase. 3,834.8 divided by 24 and we end up with an astonishing 159.8, so almost 160 tanker trucks of oxygen just to fill one Starship, and that does not take any leakage into account. The numbers on Block 3 will go up even further, likely passing the 4,000 tons of liquid oxygen per stack. Taking the Block 2 numbers and saying SpaceX wanted to do one launch per week, which is likely lower than what they want to achieve, that's almost 23 oxygen trucks per day. Plus methane, plus lots of nitrogen to keep the gases cooled down. Highway 4 would constantly be clogged up just by the tanker trucks moving in and out. That won't work. The facility will span a 4.86-acre plot north of Highway 4 and include 20 separate structures laid out in a tight industrial footprint. 3 of them are classified as habitable with work areas for personnel. The rest are skids, tanks, compressors, vaporizers, and other industrial components, all tied into a fully integrated propellant system. What makes this notable is the location and permitting process. The new ASU will be situated more than 70 meters inland from the vegetation line, thereby avoiding critical dune zones. Even so, the build will affect about 715 square meters of dune vegetation and displace 356 cubic meters of sand. Construction is expected to take 8 to 12 months, weather permitting. This may look like just another industrial plot, but the strategic significance is clear. Judging by the size of the cold box at 40 meters in height, this single unit should be able to produce around 700 tons of oxygen per day. Additionally, it should also be capable of producing liquid nitrogen and argon on site. That should be enough for around 60 Starship launches per year. Starbase is becoming far more than just a launch site. It's becoming a closed-loop system. By producing its own oxygen, maintaining internal supply lines, and reducing external dependencies, SpaceX is laying the groundwork for a higher launch tempo and a more resilient Starship program. And with Starship's propellant demands only growing, this new air separation plant might quietly become one of the most important upgrades to the site all year. Do you want to see amazingly cool things like this from the air with your own eyes? Check out redlineheli.com/Felix for a once-in-a-lifetime experience and $25 off flying in a helicopter above Starbase. The Redline helicopter team is waiting for you. They'll show you the same views our photographer gets on his Starbase flights. Give it a try. We're now 4 weeks removed from the Ship 36 explosion at Massey's test site, and our latest aerial images from Jordan show that progress is picking up. Literally. The blast zone near the flame trench and static fire stand took the brunt of the damage, especially around the methane ground support equipment. Several of the heavily damaged condensers remain in place, but much of the twisted piping nearby has been cleared out. It's a big visual shift from just a few weeks ago and a sign that prep for new hardware is already underway. The ship's quick disconnect stand also fared among the worst at the site since it was actually attached to the ship. The entire framework has now been removed from the launch site and scaffolding has been set up on the static fire stand itself to assess the damage suffered. As I expected, the stand itself will very likely be refurbished. Even though it was right under the ship when it exploded, it very much looks like it didn't suffer much damage. And a few other things are visible as well. The scorched storage tent near the front of the site has been completely removed and replaced with what appears to be a parking lot for now. Also in the back corner of the site, you can see a toppled crane that SpaceX was using for debris removal right next to a pile of Ship 36 pieces, including the nose cone. It fell over right before we released our episode back then, so we never really got a chance to talk about it. Finally, at the methane GSE site, it appears the power station that was heavily damaged in the blast has also been completely removed. While things at Starbase may seem chaotic on the outside, SpaceX is dutifully churning out new ship elements inside Star Factory. We all may need a reminder that the cadence at Starbase isn't slowing down at all, and that Block 3 will still happen rather soon. The ever keen-eyed Starship gazer has given us some fresh looks at 6 new Block 3 nose cones through the windows of Starbase. 6. Recently, nose cones for ships 39 through 44 were spotted in various stages of assembly. The newest, being ship 44's nose cone, is the first time we've seen a ship this far down the numbers. They're speeding up. We're still waiting for a sighting of any of the ring sections for Block 3 ships, but they are likely not far behind. Block 3 starships will be taller than Block 2 and feature a host of other internal changes as well. It will ultimately have a total of 9 engines, Raptor 3 integration, and likely new header tanks, downcomers, and common dome to account for the increased height. The nose cones themselves may not look a lot different than the current Block 2 ones. But seeing these test articles means that it's only a matter of time until we see a bunch of fully assembled Block 3 starships. Before you know it, we'll be talking about Ship 50. We've come a long way since the grain silo days of SN5. What do you think? When will we see the next launch at Starbase? Let me know in the comments. What does it actually take to test a rocket engine? At Firefly Aerospace, the process is fast, frequent, and done almost entirely in-house. At their Rocket Ranch test site in Briggs, Texas, technicians are running one of the most vertically integrated propulsion programs in the industry. Teams are building, firing, and modifying engines all within a few hundred meters of each other. The Lightning and Reaver engines used on Firefly's Alpha rocket are tested on site with a pace that rivals much larger companies. On many days, the same test stand will see multiple engine swaps. Hot fire, tear down, reconfigure, and install all within a single shift. And when there's a lull between launch campaigns, Firefly brings out development hardware to trial upgrades or new components. That kind of feedback loop between design, build, and test has helped the company iterate quickly and reduce turnaround time between launches. Right now, the team is also testing Vera, the second stage engine for Firefly's upcoming Eclipse vehicle, and development work on Miranda, the larger first stage engine, is well underway. Both use the same infrastructure as Alpha, with minimal changes, allowing Firefly to scale up engine testing without building an entirely new facility. What makes this setup stand out is how much of it is controlled on site. About 80% of the Alpha rocket is built internally, including carbon fiber tanks, turbopumps, and valves. Leak checks and pre-burn prep happen inside the same facility that manufactures the hardware. Then the engine is wheeled down the road for firing on one of several test stands. From there, engines track real-time data such as flow rates, temperatures, and combustion stability. Everything needed to validate performance or flag issues before flight. For Firefly, this test cadence is not just about Alpha. It is part of a larger push to scale up internal capabilities as the company moves toward full-scale operations on multiple vehicles. The speed of that work comes down to infrastructure and a team that is built to work in sync, even if not everyone came from aerospace. The company still has major milestones ahead, including Eclipse development, scale production, and ramping up launch cadence. But if their engine test rhythm is any indication, Firefly is pushing forward quickly and doesn't seem to be slowing down at all. Firefly likely has a bright future ahead. NASA's James Webb Space Telescope has turned its eye on one of the most famous cosmic collisions ever captured, the Bullet Cluster. And it produced the sharpest ever map of dark matter within it. This is the latest chapter in a long-running investigation. The Bullet Cluster is the site of a massive collision between two galaxy clusters, located about 3.9 billion light-years from Earth. It's been one of the clearest observational cases we've ever had for the existence of dark matter. When clusters like these collide, the galaxies glide through one another, but the hot gas slams together and slows down. Dark matter, being invisible, was inferred by watching how it pulled on background light through gravitational lensing, appearing separate from the gas. That separation is the smoking gun. It tells us that most of the matter in this cluster is invisible, non-collisional, and clumped around the galaxies. Now, James Webb has provided a far more detailed picture. For the first time, astronomers used Webb to detect light from intra-cluster stars, billions of stars that were flung out of their galaxy during that collision. It's a tragedy on a cosmic scale. Their combined glow helps trace the gravitational structure of the entire system, giving scientists a more precise map of the dark matter halo. So basically there should be light, but the dark matter is blocking it. And that new map has revealed something strange. One of the subclusters shows an elongated hammerhead-shaped dark matter structure, not what you'd expect from a simple head-on impact. Is it a spaceship? Researchers believe this subcluster may have collided with another system long before entering the bullet, meaning we're seeing two layered collisions. But even with this detail, the observed impact speed still exceeds what our current cosmological models predict. These fields of research, even if hard to understand, are an excellent example of showing what we don't know. Dark matter seems to be an integral part of our universe, and we still have no clue what exactly it is. The James Webb Space Telescope's data tightens the upper limit on how strongly dark matter particles might interact with each other, but it doesn't yet solve the core mystery of what dark matter actually is. Understanding the distribution and behavior of dark matter in galaxy clusters helps constrain the kinds of particles it could be made of. Astronomers are now measuring as many cluster collisions as possible from different angles and distances, hoping to pin down their properties. And if they can pair that with results from underground dark matter detectors like Lux Zeppelin in South Dakota, we may finally get an answer to one of the most important questions in physics. What makes up the 85% of matter we can't see? That's it for today. Before watching the bloopers, remember to smash the like button, subscribe for more. This is what fuels the algorithm. This is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. A new Raptor design and our Flight 9 shirt are both up. Link is in the description and in the card you should see now. And if you want to learn more, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. The upcoming roaming space telescope.